Alright, hello everyone. This is page 5, and we're going to do problem 11 and problem 12. Now, the first problem is determine the measure of angle C in degrees of the isosceles triangle shown below. Okay, well, I know from several problems, and also when we cut up the triangles and we cut these corners here, that the sum of the angles of a triangle are going to be equal 180 degrees. Okay, so now I just need to add up all of the angles in this triangle, which is going to be 58 plus 58 plus C should give me 180. Now, that's that problem. I'm going to do another one. I want to model one that's slightly more complicated. I'll do isosceles triangle again. Let's say this is 24. Actually, that doesn't quite make sense. I'll do this is 78. This is 78, and this is angle X. We're trying to solve for X. So, what we'll do is I know that the sum of the angles are equal to 180. So we'll do X plus 78 plus 78 should give me 180. So now if I just combine everything, that gives me right here, combine the two 78s, which gives me 156. But I'll just model it down here. 78 plus 78. 8 plus 8 is 16. 1 plus 7 is 8, plus 7 is 15. Okay, so 156. And now we have X plus 156 is equal to 180. Now what we'll do is we'll subtract 156 from both sides. That's kind of messy. Subtract 156. What I do to one side, I must do to both. What I do to one side, I must do. What I do to one side, I must do to. Thank you. I remember I recorded a video and I was saying that, and Carlos told me that he had said to the other, and then I immediately replied, "Thank you." And he said it was like a weird experience because I wasn't actually talking to him, but I was sort of. Okay. Anyway, these cancel here. And now I'm left with X is equal to, I'll do the subtraction right here. I'll do it in nice pink. This becomes 7. 6 minus 10 is 4. 7 minus 5 is 2. And 1 minus 1 is 0. So, my value of X is equal to 24 degrees. Hopefully now this I made the picture a little bit too small, but this is how I solved, this problem right here. You can write this down if you'd like, and it will help you with this problem. Alright? Okay, next problem. With this, I'm going to just make this a bit bigger. Okay, this corner. Okay, that's much better. Let's see. Yeah, that's better. Okay. Now we'll do this problem right here. We'll do it in black. Try to draw as neatly as possible. Okay. I know that this is 6 meters. Right here. This is 8. This is 7. And this is 13. Instead, I'm going to choose different numbers. I'm going to choose this is 12. This is 14. This is 16. and this is 13. If you notice, actually, I meant to do 16 and 13 meters. You might notice what I did with each number. Okay. Now, this composite figure, I'm going to write that down. Composite figure. So composite means made composite figure made up of many shapes. Not Snapes, we're not talking about Harry Potter. Made up of many shapes. It can be made up of this rectangle right here and this rectangle right here, or it can be made up of this rectangle and this rectangle. Okay, so now what I'll do is I'm going to figure out the area of, it doesn't matter which one we do. We can do it this way here. So what I need is the area of this well, let's do the red one first. I have this length, and actually I'm going to draw the rectangle right here. I'm given that this is 16. I'm given that this is 12. Perfect. I can figure it out. 12 times 16. 6 times 2 is 12. 6 times 1 is 60. It's 20. 1 times 1 is 100. Add them all up. Gives me 2. Sorry for the technical difficulties. So if I add them all up, it's 2. And then it's going to be 1, 6, and 7, and 2. So that's 9. And 1 here. So this part right here is 129 meters. Meters squared. So this rectangle is 192 meters squared. Meters squared. Now we just need to figure out this rectangle right here. So we don't know this length. We're not given it. We're also not given this length, but we will be able to find it out using a couple different methods. I know that this length right here is 12, and therefore if I stretch it all the way across here, I know that this part right here is also going to be 12 meters. So now I just need to find out what this part is right here. Well, it's given to me right here. So I'll choose a different color. 1 second. Choose yellow. Make it nice and bright. Okay. This part right here is 14, so I know that this part right here must also be 14 meters. So I'm actually going to erase this and draw it in black. It's a little hard to read. 14 meters right here. Oops. 14 meters. So now if I add all these up here, that's going to give me 12 plus 14, which is equal to 26 meters. So let me just draw a bigger version of the same rectangle. We figured out that this is 26 meters here. And now we just need to figure out this length or this length. And then we'll be able to figure out the area of this composite figure. Well, if we look up here, that's going to be a mistake. I'm sorry, one small thing. This should be, oops. I forgot to double this right here. So I doubled the 6 and 12 and the 13. It should be 26 26 meters. That makes more sense. Because before, this was 13 and this was 16. So how can this side be shorter than this side? It doesn't quite make sense. Okay. So now, pick a nice orange. I'm trying to figure out this length right here. But I know part of it, I know more than I need. But how do I just figure out this length right here? Well, if I know that this part right here is 16, I know this part right here is also 16 meters. And I know that the whole thing is 26 meters from here all the way to here. I'll draw that. This distance. So, and if the 16 meters stretches from here to here, I just need to subtract the 16 from the 26 to give me this x. 16 plus something, so 16 plus something should give me the entire distance here. So, I'll go ahead and subtract the 26 minus 16, which gives me 10. So I know that now this part right here must be it's not working, sorry, 10 meters. So this is 10 meters. So 26 times 10 is going to be 260 meters. Now, I'll go ahead and write that in here, 260. I'll take the 260 plus the 192. Let me just add the units, meters squared. I'll go ahead and add 260 plus 192 is going to equal this is 2, 9 plus 6 is 5, carry the 1, 452 meters squared. Total composite area. Okay. Let's see. Zoom. How do I zoom? Oh, that's as much as I can zoom out. Okay, so in summary, what I did, composite figures are made up of many shapes, and what we do is we break the shape into two parts and eventually add the areas of each shape, find the areas of each shape, and then add them. So we had the 16 times 12, that was the easy shape. And then here what we had to do, we had to get a little tricky. I know this was 14, and this part here was 12. 14 and 12, this entire distance here is the same here, which is 26 meters. So we've got the length, now we just need the width. I know that this part is 16, so this also must be 16. And the entire length, which was given, is 26. So if I subtract the 16 from the 26, it should give me what's left over here, which is this length, which is 10. And then multiply 26 times 10 gives 260. Add the two components together, and I get 452 meters squared. Hopefully that, I'll leave it at this part right here. Hopefully this will model how to do this problem right here. Thank you very much.